Okay, so here's an example where I work through an improper integral that has an infinite discontinuity. So what makes this integral improper is the fact that it's got an infinite discontinuity when x equals 5. And so this is our improper limit of integration here. That's the one that needs to be expressed as a limit. So I'm going to draw the number line again. Because I think drawing the number line with your interval of integration, so in this case from 1 to 5, helps a lot with seeing how we need to set this up. So 5 is the, we've got a vertical asymptote at x equals 5. So we can't integrate it at 5. Instead, we integrate it from 1 to t and take the limit as t approaches 5 from the left. Right? We're not approaching 5 from the right at all, because we're just trying to integrate from 1 to 5. We don't care what's happening beyond 5. So this is a one-sided limit approaching 5 from the left. So expressed as a limit, this is equal to the limit as t approaches 5 from the left of the integral from 1 to t of 1 over x minus 5 squared dx. Okay, so that's half the battle once you've got it expressed as a limit accurately. Okay. Now we need the antiderivative of this 1 over x minus 5 squared. I'll do a little scratch work on the bottom here, I think, in evaluating that. So for the integral of 1 over x minus 5 squared, we can integrate that with a u substitution. If u is equal to x minus 5, then du is just equal to dx. This is a pretty straightforward one. And so this is the integral of 1 over u squared dx is equal to du. So this is the integral of u to the negative 2. If we apply the power rule, the antiderivative is u to the negative 1 over negative 1. And so put the negative in front, u to the negative 1, that's 1 over u, which is x minus 5. Okay, so there's our antiderivative. So when I plug it in up here, I don't need the plus c if I've got limits of integration. So this is the limit as t approaches 5 from the left of, okay, we've got an antiderivative, negative 1 over x minus 5 to the first, evaluated from 1 to t. And so this is the limit as t approaches 5 from the left of, substitute t, that's negative 1 over t minus 5, minus substitute 1, and that's negative 1 over 1 minus 5. The limit only applies to the expression of t here, so I'm already separating out. When I plug in a constant, the result's just going to be a constant, and the limit of a constant is just that number. So I'm not even considering this as part of the limit anymore. Okay, and then we could go ahead and evaluate. So this is 1 over negative 4. Got a lot of negatives here. Actually, maybe I'll work through the details of that in a minute. So as t approaches 5 from the left, so this thing right here has the form, let's get rid of this. This right here has the form 1 over 0, for sure. Got that negative in front. I'll go ahead and copy that down. If we plug in something slightly less than 5, remember we're approaching 5 from the left, so t is taking on values like 4.9, 4.99. So if t is, say, 4.9 minus 5, that's going to be something close to 0, but slightly negative. So you're going to have a slightly negative value here, and then the negative in front. Remember that when you have a non-zero number over 0, this is approaching positive or negative infinity, depending on the overall sign. When you have approaching a finite number on top, 0 on the bottom, that ratio is either increasing or decreasing without bound. In this case, we've got a negative in the denominator and a negative in front. That's going to give you a positive overall. So this limit in front is approaching positive infinity. and then minus negative 1 over negative 4. We could sort out the negatives there, so that's 3 negatives, so this is going to end up being minus 1/4, but it doesn't really matter. I mean, we don't really need to mess with this at all, because we see it's a value that's increasing without bound, so a very, very large value, minus negative 1/4. Who cares about that? This is increasing without bound overall. And so if this limit's approaching infinity, then we say that the integral from 1 to 5 of 1 over x minus 5 squared diverges. So our answer here, and for problems like this, when you look at the back of the book, it's just going to say diverges. Okay, so now that you've sat through that, your quiz question. Very similar problem. So this is quiz number 7, question 2. I'm embedding it in this video to be a real stinker. But so, oops, I had it all picked out. It's the integral from 3 to 4 of 1 over x minus 3 squared. So maybe even overly similar problem. But so this is your quiz question 2 to evaluate that improper integral. Tell me if it converges or diverges. And if it converges, what it converges to.